The hallmark of a unit vector is that its magnitude is 1. That's what makes it a unit vector in particular. I can make a unit vector in the same direction as any given vector by dividing it by its magnitude. Which is essentially scalar multiplication by 1 over the magnitude of each of the components. Let's take a look at this specific one. I have the vector A, 3, negative 4. I got my scale kind of big here. 3, negative 4 is there. There's my vector A, and I want to make a unit vector out of it. So it sounds like I'm going to need its magnitude, and we can do that. The square root of the first component squared plus the second component squared. Nice 3, 4, 5 right triangle. Magnitude of vector A is 5. So a unit vector is going to look like 1 over the magnitude, and I'm going to multiply through my vector 3, negative 4. So my components of the unit vector are 3/5, negative 4/5. Taking a look at the picture here, this is why I kind of blew up the scale. 3/5 is, I don't know, maybe there. It's a little bit more than half. And 4/5 is a little bit less than 1, something like that. So my vector, 3/5, negative 4/5, about there. It's in the same direction as my original vector A, but it has a length of 1. And just to convince you of that, let's take a look at the magnitude of 3/5, negative 4/5. 3/5 squared and negative 4/5 squared. Negative 4 squared is 16. And I get the square root of 25 over 25, but 25 over 25, that's 1. Square root of 1 is 1. So 3/5, negative 4/5 is indeed a unit vector. We can think of unit vectors in the direction of each of the axes. We'll call them standard unit vectors. If I think of a vector of magnitude 1, pointing in the direction of the positive x-axis, looks like that, and it has a name. We call it I. It's specifically in the positive x direction, so its component form is 1, 0. If I do the same thing in the positive y direction, little vector in the positive y direction of magnitude 1, we'll call that one j, and its component form is 0, 1. I can write any vector as a combination of I and j, these two standard unit vectors. So my vector A over there that we've been using, 3, negative 4, I could equivalently write as 3 in the positive x direction and negative 4 in the y direction. These two pieces of notation here are completely equivalent. They're two different ways of saying exactly the same thing. If you're a physics person, you might have used these standard unit vectors to express a vector, and you can, whichever one you like better, you can use, because they're both perfectly good ways of expressing vectors.